Hello, hello. Welcome to today's webinar. I'm excited to be here. My name is Jeffrey Palermo, and we are going to go through how to achieve stability, the last mile to return on investment. And this is from one of the topics that I do touch on in my latest book, The Five Pillars, which I'll show you in a little bit. But that's what this training is all about, is achieving stability in the running of your software in a production environment. And it's really the last mile until we can start realizing that return on investment in the software, what we've been working so hard to make come to fruition. Um, sometimes uh, sometimes quality refers to everything good and the absence of anything bad. Um, but there's a difference between how a software system should work and how it works right now. It doesn't matter how well your laptop computer was designed, built, and tested, or how long it's worked flawlessly for you. It only matters how it's working right now. And if you have some basic computer problems right now, then your computer is not working as it should. You have a problem. And this is the concept of stability. It answers the question, how is the software working right now? And that's what we're going to dive into today. So ClearMeasure is a full-service software architecture and engineering firm that serves companies that are using .NET and Azure and other Microsoft technologies. We do three things. We build mission-critical software systems. We rescue and assist projects that are not in a good spot. And we do inspections and advice, always empowering software delivery teams with a proven approach. And so we're available for help, for advice, to inspect your software, inspect your team, inspect your architecture, um, or to actually come alongside you and help you to implement certain things, get you over the hump, or to develop full pieces of software. So that's what we do, and we're available to help. Just give us a call. Our agenda for today is what you see on the screen. We're going to talk about the industry challenge that's before us and how the industry is doing with regards to stability. We're going to define it a little more clearly, and then we're gonna talk about the costs of instability, just so that we can strategically think about this. We're going to talk about recovering from issues quickly and how to prevent stability problems in the first place, and then how to protect it once we have achieved it. As I mentioned, I just published another book called The Five Pillars: Leadership for Effective Custom Software. And if you want a team, a software team, your team, to deliver world-class results, then this might be a good read for you. It doesn't have pages of samples of code. It has principles of how you should think and organize your software engineering team so that you can do just a really, really good job with whatever software that you're working on. And a special offer for today, for anyone listening, if you just send me an email, which I have Chloe in the background manning the chat, and she's assisting with that. Anyone who wants to send me an email or do the request form at the link in the chat, you can request an electronic copy of the book, and we'd be happy to get that for you. Also, teams are using the study guide to have really introspective team discussions. And it's not about studying the book, it's about studying your software team and getting better together. And so we'll put a link to the study guide in there as well. And for team leaders, we have our software architect forums that meet monthly. And so if you are the head of a software engineering team, if you're in that role, then this peer discussion group may be of benefit to you, because we recognize that there's professional development opportunities for programmers. Those are everywhere. You can learn how to basically use any technology with videos online, but how to function in a technical leadership role, that's a little bit harder to find. So this helps that issue. So go to clearmeasure.com for the next software architect forum, and we'd love to have you there. I personally facilitate those, and it's a meeting, it's a group discussion over video call with other peers in the industry. Okay, so let's keep going. Um, okay, stability. Let's talk about what we're really after. When our software system is stable, it's doing its intended job. Just think of a ladder. If the ladder is shaking, I don't want to be using it. But when the ladder is planted and it doesn't move, even when I put stress on it, I can confidently use it to get my job done. I can stand on it. I know it's not going to fall. And let's think soberly about our software. No one really wants to use software. Just like no one really wants to use a drill. But if I need a hole in something, I use a drill to give me a hole. And I use software when I want to do my job better, faster, in a more automated way. A stable software system, it kind of fades into the background and lets me do my job without thinking about the software system at all when it's a good one. But when it has some glitches or some times when it's not stable, well, now I'm distracted from my job. And then I start thinking about the software itself instead of doing my job. And our goal is to produce and run stable software systems in production that enhance our customers' ability to really compete in their marketplace and do whatever they do for their customers and ultimately drive earnings for the company. Okay. So that's the goal. Now, the technology industry really they put so much jargon into this concept of stability over the years. It's filled our vocabulary with all kinds of quote non-functional requirements. And so, uh, what are some of those? Well, there's performance, there's reliability, there's scalability, there's security, there's fault tolerance, there's recoverability. All of these terms are really the same concept stability. And this list is going to grow as more bad things happen to software systems over the years. The list, just by its nature, is an ever growing number of categories by which something bad may happen unexpectedly because bad things have happened in the past unexpectedly. And whenever these things happen, these events, these challenges for the software system, the system really should just be able to handle it. And so here's our non jargon definition of stability. A stable software system will continue to perform its intended function regardless of how users may abuse the software. And that's really it, without disruption. The ability of a software system to continually perform its intended function without disruption. That's stability. Okay. Users are going to abuse the software, but regardless, it shouldn't break. Regardless of hack attacks, usage spikes, downstream failures, the system, it should not cascade those problems into a business disruption. After all, that's really what we care about. You need to be able to keep business moving, and the software system is really just a tool that enables that without um, without breaking the business. And with any software initiative, immediately after uh, establishing quality, which is the last webinar we had the previous topic, um, right after establishing quality, your next priority has to be achieving stability as your software system runs in production, serving its intended purpose. This is really your quote last mile to the return on investment you've counted on from the beginning of your software project. Okay. Now, um, let me give you an analogy. Most auto manufacturers participate in racing of some kind. And happen to live in Austin, Texas, and just recently, NASCAR came to the Circuit of the Americas track that was really built for Formula One. So it's not just an oval; it's got lots of 20 different turns, hairpin turns, and so that was a fun race and very stressful, and it took some of those machines to the limit. But most of these auto manufacturers they participate in racing of some kind, and it's more than just marketing; it's also research and development. New technologies and methods they're tested in racing scenarios because the stress level on these designs is immense. And the race environment is hard to predict. And there's surprises that happen all the time on the racetrack. And if you really think about it, where else can auto companies find out the limits of their designs, their engine, the exhaust, the suspension, all those different systems? Another environment is crash tests. Auto companies use these to make their products better on the road. The crash test doesn't find the limit of a bumper or a frame. They know the car is going to be a total loss. And so they want to find the limit of the entirety of the car and still keep the passengers alive. The question answered in these is quote, how bad is it going to be when this happens? And with every important machine, not just cars, with every important machine, figuring out the limits and how it breaks is part of making it more stable as it's used daily. Okay. Software included. We have to know its limits. Um, Now, I want to talk about some of the costs of instability, why it's so important that you actually give this some mind share. Unfortunately, there's plenty of information on software systems that have behaved poorly. There's outages and errors. The financial impacts have been enormous across our industry. Uh, Atlassian, the maker of the popular Jira tool for service management and work tracking, they've compiled some pretty stark numbers on the costs of poor software quality. And here are some of the highlights directly from Atlassian. For problems that result in employees being unable to do their jobs, large companies can lose an average of $5,600 to $9,000 per minute. In smaller companies, less, but averaging between $137 and $417 per minute. And this is data from companies that have shared these costs, and they keep happening. Going back to Christmas of 2022, that was a disaster for travelers using Southwest Airlines. Every flight was grounded because of a software failure. Reuters News reported that the costs have exceeded $1 billion and counting. But your numbers that high, they'd be disastrous enough even if they lacked a little bit of accuracy or precision. Those are huge numbers. But beyond just outages are the secret internal incidents that are either mini outages or periods where employees are just hindered in their work, disrupted in some way. We all experience it, even if indirectly. It seems to always happen. You call a company and the person on the phone, they casually mention that they're having some type of system issue or my system's running poorly. And the call, it just takes way too long because you're not actually talking to the customer service rep. You're waiting for them to finish using their computer or ordering food at a restaurant. It's, the waiter could be apologizing because they have a new system and it's having issues. So stability problems, they really inflict a lot of paper cuts everywhere. And beyond employee productivity losses or lost revenue, every stability issue bypasses your normal user support staff. And this is inherently so. This is important. If the normal user support staff had a knowledge base article on how to work around the current issue, well, then we wouldn't even call it a system issue. It would just be the normal day-to-day user support. And after all, we have a searchable knowledge base article for it. Uh, you know, every company that has outside software customers do, and it's normal because we expect it. We expect it to happen again, and because that we've documented the steps to get past it quickly. All right, so there's a difference. So what to do? I just said stability problems bypass the support team. They go straight to the software group. That's the problem. As we saw just a minute ago, quality issues um, are something we have to get past first because they steal our team's capacity. We talked very detailed in the quality training about how quality issues steal our team's capacity to work on new software features. Stability issues do this as well. And they're worse because stability issues force the team to switch priorities to something that has absolutely no relationship to the line of work that's been top of mind in the current day or the current week. When this happens, the team is blindsided and surprised, and it's really put into immediate stressful position that has a lot of urgency in a lot of cases. When these stability problems happen, the personal things in the evening, like little league baseball games or school band concerts, those have to be put by the wayside and made a lower priority than getting the system back to normal working order. Now, if your users go to bed or stop using the system at 5 p.m., that might not be applicable for you. But if the system, absolutely, if that problem cannot wait till the morning, you can't just say, "Hey, sorry, I'll do it in the morning," because effectively your business could be, dead in the water depending on the issue. A lot of stability issues are devastating. You should know two concepts as a software leader, and certainly the executives overseeing a software team, they have to do a really good job overseeing these two concepts with any software project and with any software system. The first is quick recovery, insanely quick recovery. And the second is total prevention. Okay. We want to prevent every destabilizing stability issue, every disruptive production issue. I'm not talking about little issues that happen and are not disruptions. For instance, we track issues in a technical service system all the time. It may be, hey, clear out log files or clear out, temp files in a directory so we don't fill up a hard drive or archive or do a check on the database, backup and restore. Those, yeah, they may be we call it an issue because we have to do some work on the production environment. Those are prevention, because if we didn't do them, something bad would happen and then it would be a disruptive issue. We're talking about total prevention of disruptive issues in production. So these two concepts, quick recovery and total prevention, these are the building blocks of stability. And a strategy for recovering quickly when an issue occurs, you need that. And you need a strategy that results in the prevention or severe reduction of every issue. On your dashboard that you track for your project, you should have numbers. You must measure stability. You have to know what it is. And if you aren't measuring something, you're blind to it. You're just rolling the dice. For recovery, there's an industry standard metric. It's called MTTR. It stands for mean time to recovery or mean time to resolution. When an issue is reported, it's the calendar time until it's resolved. And every incident tracking system really gives you this type of information for free. It's not really something you have to invent, but it is something you have to track. Every incident of every severity. If the process is just that, Sally calls Joe and asks for help, then Joe needs to record the reported issues so that the clock starts quickly. But the modern incident tracking systems have easy reporting processes, including features that listen to specific email addresses and even automatically log a new incident or issue. That part's easy. You just have to make sure that your scorecard is reporting the number of issues and the mean time to resolution, the MTTR. And only then really can you estimate the cost of the instability for your organization or for a particular system. Now we start with measurement because that's how you know the score. That's how you know if you're ahead or if you're behind in this game of software. If you don't have any numbers on the scorecard or you don't know how to read it, then there's no way to gauge your progress. In the game of software, with stability, recovering from incidents has to be lightning fast. The next part of the strategy is the mechanism for recovery. And there's two parts to this. because you got to have this capability. First is optics. That's the visibility into what the cause of the problem is. And the second is the ability to make and roll out system changes very, very quickly without introducing new problems. If you haven't prepared beforehand, you won't have number one or number two. And the right type of optics are used to determine what a system is doing. And that's called observability. If you've researched the latest enhancements of telemetry across the industry, open telemetry, the new standard, that's all kind of under the umbrella of observability, knowing what the system is doing. And the good news is that the tools and the libraries around open telemetry are pretty darn mature at this point. But you have to make sure that it's implemented. With it implemented, your team will be able to see exactly what led to the failure or the disruption, and that's going to shine a bright light on the root cause of the issue. And once your team knows what led up to the problem, the root cause, it becomes, pretty darn apparent, and the problem can be solved pretty quickly. The solution to the problem, it may be an infrastructure configuration change. You just do a server restart or a particular process restart, or maybe you do need to do a code change. But regardless of what the proper solution is, your team needs to have an insanely short cycle time to make changes to the system. And this cycle time will be the same duration as your team's time for making any other small little configuration changes. All right. And if your team can't like make any kind of small changes quickly and regularly, then don't expect them to do any better when you actually have a stressful situation. So here's a good test. A good test is to, let's say, request a single word change somewhere in your system. For example, maybe on a screen or a drop-down menu. See how long it takes to make it happen. This will give you some sense of the average or minimum cycle time for your team just to do anything. All right. And after knowing the solution of what to do, you can kind of count on this baseline cycle time for resolving any kind of incident. And your strategy around quality, that is also going to come into play here, since the last thing you want to do, last thing you want to have happen is for a new defect to be accidentally introduced while the team is making a change to resolve a stability problem. That just compounds things. All right, let's talk about preventing stability problems. The holy grail here of instability is preventing absolutely all incidents in the first place. And this is where stressing your system comes into play. Like race car teams, you want to stress your system in various ways. Your users in your business environment, they're certainly going to stress it and use your software in surprising ways that you probably never thought of. But you'll want to cover the basics, like the number of concurrent users and downstream systems going down. You want to track those basics. For example, you want to know if one person's using your software or if 1,000 or 10,000 are using your software at any given time. And you'll want to know if one of the systems that you integrate with is unreachable. If you send text messages, or if you integrate with a system to do payment processing and one of those systems is just now unreachable, you want to know that right away. So you'll ultimately, you want to be confident that your system does the right thing when various environmental things happen. Think about it. Any resource your system connects to will have an outage or system degradation at some point. It's just reality. And if this reality is absent from your design, then your stability is really a game of chance. Your stability testing should include each of these resources going down and you knowing about it. And so, do you call other systems during normal operations? Of course you do. Have you simulated them being unreachable? And have you checked what the system does when they are unreachable? Have you designed that scenario into your system so that you've chosen ahead of time what it should do? this type of modeling and planning helps reduce production incidents and reduces the severity when they do happen. It's one thing to not be able to send text messages. It's another for some function that would result in a text message to just blow up in a user's face and cause the system or that screen to crash. Same way, if your payment provider and its backup are both down, you can't run those payment cards. But if your system has some degraded um, behavior instead of just that crash, that's that's a lot better than the crash. So early warning of a coming incident is fantastic prevention. The concept of a health check, for example, is really essential for all running components of your system. This is fantastic prevention and early warning. Going back to auto manufacturers, cars usually have a plug under the dash. Mechanics can plug in an OBD2 device, and they can complete onboard diagnostics and pull error codes from most modern cars. This is a well-worn pattern for complex machines of all kinds, and your software system is definitely a complex machine. There's plenty of libraries and tools available for built-in diagnostics and health checks. Your system dashboard should have green lights for every running component of your system so that your team knows when one of the components becomes in a state that's any less than completely healthy. Early remediation of these events can prevent a lot of stability problems that do occur from becoming production incidents where there's disruptions. All right. So let's move from just initially achieving stability to protecting it. And whether you have long-standing experience with a software system or a brand new software system that even isn't yet in production, achieve stability now in the environment that it's running in now. Don't wait. It's not something that just simply happens. It's caused by intentional strategy and execution. Um, Resolving stability problems requires changing production in the middle of the day. That is so important. When you have a stability problem, you're going to change something about production in the middle of the day. So, what does that mean? Your team should be deploying changes in the middle of the day anyway, all the time for any new feature as just a matter of course, so that it is just normal and a habit. You want to practice like you play. Measure how you're doing. Take action to improve the numbers you don't like. Quick recovery, the mean time to recovery, how many issues are are disruptive to the business, how many issues have to be escalated to the software engineering team. Improve the numbers you don't like. Watch the numbers like a hawk. Get your team to watch those numbers. By achieving stability, your team will be highly effective at delivering mission critical software systems. All right. Just to ground you again, achieving stability is the third of the five pillars. And so if you're implementing the five pillars kind of from the beginning, you've created clarity on what you're doing, how you're organized, what the whole point of this software system is, what your process is, what your architecture is. Then you establish quality. You make sure that you're not just wasting time thinking that something was finished and good, only for it to come back and realize you have to rework it. You have to establish quality. Then we achieve stability, which is what we just talked about. The follow-on training session will be about increasing speed and then how to optimize the team and circle back with a feedback loop, right? Um, all right, let's talk about practices for achieving stability. What you see in front of you is a highly shrunken technical blueprint for the structure and flow of a pipeline that happens to be implemented with Azure DevOps and Octopus Deploy with continuous integration, has CI build and a three-tier deployment pipeline. You absolutely have to have a complete development environment. So whether you like to call it a DevOps environment or development environment, the way in which you work, and it needs to be a pipeline. It needs to have flow. And we encounter a lot of teams that implement a triggered compile and call it continuous integration. That's only one of the three um, stages of continuous integration. If you would like a high resolution copy of this DevOps poster, then just request it in the chat or send me an email. This is only the top third of the poster. It's meant to be printed on 2 foot by 3 foot paper at a print shop or whatnot. Go ahead and you can download that here. Also, you'll probably want to just look at this video, the history of DevOps. Uh, the original, um, the original creator, Damon Edwards, he was originally going to call it Agile System Administration because he saw what the engineering practices that Agile software teams were using with continuous integration and automated testing and design patterns, and wanted to apply that to system administration, which was, 15 years ago was still largely a manual affair. And so he kind of gave a presentation about applying Agile and automation to system administration that ultimately became DevOps. So if you are using any elements of Agile in your software system, in your projects, then you can extend it into DevOps because it's the same mindset. All right. Okay. And as we close up, I want to remind everybody of the Five Pillars Software Leadership book. We'd like to get a copy in everybody's hand. You can send an email for a electronic copy, or you can find it on Amazon or audible.com. And also, I don't have a slide for it, but um, ClearMeasure has a software engineer open position we are hiring for, and we do not hire from our clients. So uh, if you happen to be from one of our clients, just kind of system of respect, we don't do that. But anyone else that knows someone who might be a good fit to be a elite software engineer at ClearMeasure, part of our software architecture and engineering practice, then we are hiring. You can go to clearmeasure.com and get information about that. Of course, if you have any questions, just send me an email, and I'd love to chat. And my phone number is in the chat as well. So I was able to answer some of the questions during the training session. But if there are any follow-ups, I highly encourage you to complete the 5 series training on the 5 pillars, the video training course that you can find on our website. And it includes all of the pillars: create clarity, establish quality, achieve stability, increase speed, and optimize the team. And then get our study guide and have those conversations with your team and ask those tough questions and get better as a team. And we love empowering software delivery, and our vision is that every software team worldwide would deliver absolute amazing results for their customers and businesses. So thank you so much for coming to this training, and we'll close it here. If anybody does have any additional questions you want to put in the Q&A window, be happy to hang out and chat for a bit. Thank you so much.